one another. That just meant that x is y. We went to equation 3, we replaced the y with x, common denominator, put together, multiply both sides by x squared, solve for x plus or minus. And then that's also y, right? So far what we have is this. We have that if x is root 2, y is root 2, and lambda is something, right? Who cares? And then we have negative root 2 and negative root 2, and lambda is something I don't really care. And there was no restriction, right? Like we didn't say, suppose x is not 0 and y is not 0. So this should be it. These should be the only two things to consider, right? How do y'all feel about that? Does that feel all right to you? So we need to plug in f of root 2 is 1 over root 2 plus 1 over root 2, oops, which is 2 over root 2. And we can leave it like that. Simplify is actually pretty nice. It's just root 2. If you multiply top and bottom by root 2, you get 2 root 2 over 2, and the 2's cancel. I've always thought that's kind of a weird. The fact that 2 over root 2 is root 2 just seems weird, but it is. I mean, it's not. And then if we do negatives on each one, it just gives us a negative answer, negative root 2. That should be it. Max, min. I'm going to take a look at the picture here. Wow, kind of hard to see this. Look at this surface. It's really cool looking. Really cool surface, I think. So there's my surface, right? And I've restricted it to this curve, maybe. I've restricted it to this curve. We look at the curve from the top. There it is. If we plug just those points into the surface, we get the black curve. Hope y'all can see that black curve on the surface. Let me take the surface out of here. Let me take the domain out, and let me show you our answers. There we go. So those black curves were the curve, was that blue curve restricted to our surface. It gave us these weird curves in three-dimensional space. We found the lowest and highest points. All right. Finally, we've moved on. What if, this is what I alluded to at the end of class last time, this is all great if we have a function of 2 variables subject to a constraint, but Lagrange extends into functions of 3 variables with a constraint equation. So if you have 3 variables, x, y, and z, so if your function is a function of 3 variables and your constraint equation contains 3 variables, then we still are going to set the gradients equal to, the gradient of f equal to lambda times the gradient of g, and we still have the constraint equation, but that's going to give us a total of 4 equations that we have to satisfy. We have to make sure partial of f with respect to x is equal to lambda times partial of g with respect to x, then partial of f with respect to y is equal to lambda times partial of g with respect to y, and then partial of f with respect to z is equal to lambda times partial of g with respect to z, and then the constraint equation has to be true. So we have 4 equations instead of 3. So we have to solve for x, y, lambda, x, y, z, and lambda. All right, let's do it. Now, we do have a little bit of an issue here. I can't show you this anymore, okay? I can't show you the surface and the domain on the ground and restricted, and there's a curve and we're finding highest and lowest points. Can't do it anymore because our function of 3 variables lives in 4-dimensional space. So the only thing we could maybe do is try and understand what its constraint is. So here's our function of 3, well, it's a function of 3 variables, but there's only 2 variables here. But look at our constraint. Our constraint is actually like an ellipsoid. So you're only plugging in points from an ellipsoid into this function in 4-dimensional space. And you're trying to figure out the biggest and lowest values. Let's do the first one. There's 2 different problems here, so let's do the first one. This one should work out pretty nice. Let's see. Okay, first equation. Partial f with respect to x must equal lambda partial of g with respect to x. What is the partial of f with respect to x? 8 must equal lambda partial of g with respect to x. So g is this right here, right? So 2x. Hey, while I'm here, 4 equals lambda times x. There we go. I just divided both sides by 2. That I can do, because 2 is never 0. 2 is 2. Okay, equation 2, partial f with respect to y must equal lambda partial g with respect to y. Partial f with respect to y, 0 must equal lambda times 20y. I can divide both sides by 20. Lambda y equals 0. So either lambda 0 or y 0, right? Okay, now equation 3. Partial f with respect to z must equal lambda partial g with respect to z. So negative 4 equals lambda 2z. So negative 2 equals lambda z. And finally, equation 4 is my constraint. X squared plus 10y squared plus z squared equals 5. Where do we begin? Or lambda.
Well, the lambda can't be 0 because wouldn't that make the other equations not true?
That's right.
So
I just said or lambda, right? Like we have to consider both, and when we get to lambda, it's going to be obvious we can't.
yeah.
Okay, so I like starting with this one because it's equal to 0. So we know for sure either y is 0 or lambda is 0, right? Let's start with, what do you want to start with, y or lambda? Suppose what?
Y equals 0.
So this is, yeah, we're basically basing this off of equation 2. So suppose y is 0, right? Y is 0. Then equation 2 tells us that, what, 0, 0, right? So we're good. I'm just double checking. Like that's where it's coming from, equation 2. So y is 0. What else? Is there anything else it tells us?
Means that we could use equation 1.
You could do equation
So
1.
lambda is free to be anything.
Lambda is free to be anything we want it to be, right?
So it'd be equal to 4 over x.
Yeah, now we solve
If
it.
we
You could solve,
0.
so you could solve, now you could solve for lambda here, right? But you'd have to say lambda is not 0, because we haven't said lambda is not 0 yet.
Yeah.
We said y is 0. If y is 0, well, lambda could still be 0 as well, right? Here at least. Yes?
So then at the initial start, should we say, suppose y equals to 0, then x cannot equal to 0, and z cannot equal to 0?
X
Since
cannot be 0.
That means equation 1 would be 4 divided by x equals lambda.
Or we're restricting it to that domain.
It really depends on how you want to go. I mean, this is where things really start to get crazy because we have 4 equations. So where do you go? Just got to make sure that you logically go somewhere, right? And don't miss anything. So y is 0. Y is 0 makes this true. But there's a bunch of ways to make this true now, isn't there? And there's a bunch of ways to make that true as well. So what if y is 0 here, don't you have any equation with 2 variables? But you can't solve that, but maybe there's a way we can make a connection with the lambdas? I don't know, right? Something like that? Messy. This is messy. Let's just keep going. Let's suppose this. Let's suppose this is true. Let's write some things that we all can agree on. Equation 4 becomes x squared plus z squared equals 5. Do we agree with that? If y is 0. Okay. So I've got an equation that has x and z in it, right? Maybe I can somehow use these two. This has x and z, and this lambda's in both, right? So how about we try and solve this for x and that for z? If I do that, I have to promise that lambda is not what? 0. So right now I'm going to say, in the middle of this, suppose lambda is not 0, right? Now I indented that because I want you to understand I'm still within the same assumption here, right? I'm saying y is 0, And now I'm assuming, or I'm supposing that lambda is not 0. Then equation 1 tells me what? 4 over x is lambda. Oh, shit. But now I have to also promise you what? X wasn't 0. So suppose lambda is not 0 and x is not 0, right? I just divided through by x. Oh, wait, what do we want to solve for? I did this wrong, sorry. What do we want to solve for? X. I messed up. This is...
What? I thought we were solving lambda.
No, we were solving for x to plug it in here,
Okay.
right? And then z. So when I take equation 1 and solve for x, I divide it by lambda, which is why I said suppose lambda is not 0. Okay, so now x equals 4 over lambda. Sorry about that. Similarly, what does equation 3 tell us? If lambda is not 0, that z is equal to negative 2 over lambda, right? Do you all see how this is already like more complicated than the ones when you have two variables, right? Okay, so y is not 0, which satisfies equation 2. Equation 1, lambda is not 0 allows us to solve for x and y in equations 1 and 3 respectively. Equation 4 is sitting right here. Let's use equation 4 and these two things now to rewrite equation 4. Okay, so now equation 4 becomes x squared plus z squared equals 5. Okay, what is x? 4 over lambda. Y? I mean, not y, z. Negative 2 over lambda. Square those. 16 over lambda squared plus 4 over lambda squared equals 5. Same denominator, put them together. I'm running out of room. So 20 over lambda squared equals 5. Let's multiply and divide. We get 4 is lambda squared. And so plus or minus 2 is lambda. Plus or minus 2 is lambda. So I believe this satisfies all the equations, right? This satisfied equation 2. Equation 2 is going to be satisfied here, right? Equation 4 became this, and we're satisfying that right here. Equation 1 is going to be satisfied here, and equation 3. We have all four equations are being satisfied. But we need to figure out what x, y, z, and lambda are. So let me come over here. Let's figure out what x, y, and z, and lambda are. I need x, y, z, lambda. X, y, z, lambda. And we're starting with the fact that lambda is plus or minus 2. So if lambda is 2, what's x? 2, right? 4 over 2. What's y? 0. Y is 0 because that was our assumption, right? Z is negative 2 over 2, negative 1. Right? So if lambda is 2, we get the x, y, and z there. What if lambda is negative 2? It should be, that should be negative 2. Y is still 0, right? And this should be positive 1. All right. So far, that's what we've got. Questions? Because we're not done, right? We're not done? Okay. Now, let's run back through our logic again. We said, hey, suppose y is 0, right? Suppose y is 0. If y is 0, we had this equation 2 is true and equation 4 becomes that. And then we said suppose lambda is not 0. What I'm going to do is I'm going to go back and I'm going to say suppose y is 0 and lambda is 0. So I'm going to go through the same logic but change this. So suppose y equals 0 and lambda is 0. What happens? We have a problem, don't we? Equation 1 becomes what? 4 equals 0, and that's no good. So that can't work, right? So we're not going to need to look at that anymore. So what I was trying to do is say, look, if y is 0 and lambda is not, I do need to look at y is 0 and lambda is. And when I did that, nothing good comes of it. So now what? What now?
We have to look at if lambda, suppose lambda is 0.
Okay,
Do we have to-
okay, you could just start with suppose lambda is 0. It's going to be the same thing, right? Equation 1 gives us 4 is equal to 0, which isn't true. So we don't have to worry about that. Lambda by itself. Okay, is there any other thing that we need to consider here?
That's the only things we can,
Yeah.
because of equation 2.
Yeah, because look, this was off of y being 0, right? What if we suppose y is not 0? If y is not 0, then what does equation 2 tell you? That lambda has to be 0. But then we contradict ourselves on equation 1. You see that? If y is not 0, then that equation has to mean that lambda is 0. But if lambda is 0, that implies that, from equation 1, that 4 is equal to 0, which is not. So as soon as you try and let this not happen, you have a problem. So this has to happen, and when this happens, this is the only result, right? Those two things over there. So we've pretty much covered everything.
So you would expect us to go through and cover all those hypotheticals, even though we can technically see that they can't be possible?
As long as you show me that lambda being 0 causes a problem, then I think that'd be okay. But you need to consider it.
So we would have to show the first one where we would do like y equals 0 and lambda equals 0, but then we wouldn't have to show the next.
Yeah, these two are really just more to kind of make sure you truly understand that you've gone through all the possibilities.
What if we set c equals 0?
If z is 0, the reason why we never looked at that is because, the reason we looked at y as 0 is because these two multiplied to be 0, right? Here, I can tell right now that if I let z be 0, it doesn't work, right? Same, no, don't apologize. I mean, it's important to see why we chose y as 0, right? When we had these three equations here, the reason I went after this one is because that had 0. And that's what it was like, okay, I know for sure the only way to satisfy this, right? The only way to satisfy this is if lambda is 0 or if y is 0. I don't care what's happening everywhere else. At the end of the day, I have to satisfy this, right?
Yes, sir.
So all four have to be satisfied together, right? So if you can get one that's down to just two options and you consider both those options, then you're done. Yeah. Yep, no, good. All right, you ready to look at the next one?
I have one more question.
Yes.
So previously, we had just f of x and y. We had to plug that into the original.
Oh, I never did. I never plugged in.
No.
Yeah, I'm sorry. I need to plug in. I'm sorry. I got sidetracked there. I apologize. Yeah, I never plugged in to figure out what was max or min. So, yeah, you'll have to tell me what they were. It was 2, 0, -1, and 2, -2, 0, +1, right?
Yes.
Okay.
Would the original equation have given us a hint that y had to be 0 because there is no y? Or is that negligible and built into?
I think in this particular problem, yes, because that's like a plane equation, but generally speaking, no. All right, so checking now, we need to do f of 2, 0, -1, and we have to do f of -2, 0, 1. Can y'all double check for those points? Right, you don't use lambda in there. 8, 16? No, 12. 12, right, and,
No, it'd be,
no,
because it'd be negative.
16, and then
It'd be +4.
plus 4. 20.
Yes.
And then minus 20? There we go. All right, so that's your max. 20 minus. You have to take a step back and kind of appreciate what we're able to do here. We have a function that you can plug three things into. In this case, y is not there, but you can plug in three numbers, x, y, and z. And I'm asking you, what's the biggest this will be and the smallest this will be if the only points you're allowed to plug in are the points that live on this surface, right? I mean, this is like an ellipsoid looking thing. If you can only take points on that surface and plug into that, what's the biggest value you get, what's smallest? That seems like an extremely hard thing to do. I think we did it with relative ease. Was that relatively easy? I think this one's even more, you can appreciate this more, right? Even more. You've got this function that takes in 3 different variables. And you're only allowed to plug into it points that live on this, what is this? Sphere of radius 1. That's x squared plus y squared plus z squared equals 1. So imagine you have these points on this sphere. There's an infinite number of points on this sphere. And you take that point, the x, y, and z, you plug it into this function. What's the biggest and smallest values you can get, right? Well, we're about to find out. Okay, partial f, equation 1.
2x, y squared, z squared.
So 2x y squared z squared equals lambda times 2x. Okay, equation 2. I'm trying to go a little smaller here. Hope that's okay. 2x squared y z squared equals lambda times 2y. Equation 3. 2x squared y squared z equals lambda times 2z. And then you're constrained, right? All right, why don't you take a minute to see if you can figure out. I'm gonna step out and get a drink real quick. One thing I would recommend before you begin, just divide both sides by 2 on all of these, right? Because you have 2's there. Just get rid of that 2. It'll just make it a little cleaner for you, right, to not have to deal with that. See if you can't figure out an attack on that while I just go get a drink real fast. A little tricky.
I mean, aren't they all kind of equal to each other? Would you not want to
They're
divide?
similar to one another.
Would you not want to solve each of them for lambda?
Would I not want to? Would you not want to? I don't know. What do you want to do? Are y'all thinking solve for lambda on all these? Okay. I'm okay with that. And then set them equal to each other? Are y'all all right going down that road or no? Someone try something different? No? Go for lambda? All right, I'll go for lambda then. But we got a lot of things to assume, right? All right. So if we're going to solve for lambda on this one, we have to assume that what? X is in 0. And then you can divide by x. Here, y is not 0, and you can divide by y. And there, z is not 0. So we're going to have to suppose that x is not 0, y is not 0, and z is not 0. Now, just before we do this, I want you to think about this. That means that when we're done with this, we're going to have to go back and we're going to have to say, okay, what if x is 0, y is 0, and z is not? Or what if x is 0 and z is 0, but y is not? Or what if y is 0 and z is 0 and x isn't? Right? So there it becomes to present. I mean, we have, yeah.
All right, so what's
Okay.
the way to do
What?
this? Is it okay? So what's the right way to do
Yeah, no, we're doing it. This is it. This is it. I just want to keep in mind that if you're going to assume that all three variables aren't 0, then you're going to have to later look at when they all are, or maybe just two of them are. You're right. You're going to have to look at all these different scenarios. So, okay, let's do this though, because I think if we do this, we can take equation 1 and just tell me, what does equation 1 become? Lambda is what? Y squared z squared. And then equation 2 becomes lambda's x squared z squared. And then equation 3 is lambda's x squared y squared. Okay, now you can start setting these equal to each other, but let's just do 2 at a time. Okay, so let's do these two together first. If we do that, those two together, then we get what? It starts to become messy. Y squared z squared equals x squared z squared. Can I divide z squared on both sides? Yes, because I'm assuming z is not 0. See, I'm assuming z is not 0, so I'm okay to divide by z squared. If I wasn't assuming that, then I would factor and move things over and factor. But that means that y squared equals x squared. Now, does that mean x equals y? No, this means that x equals or y equals plus or minus the other one. So I'll do it this way. Y equals plus or minus x. You have to take square root on both sides. Yes?
Could we also go back to equation 3 and it says lambda is equal to like x to the 4th?
Lambda.
If x squared is equal to y squared?
Oh, you mean right now, can we come here and say lambda is x to the
Is
4th?
it x squared
Yes.
times x squared?
Yes.
I don't know if that would help. But
Well, maybe. If we need lambda, that'll be the relationship, right? If we need lambda. I don't know if we'll need lambda yet. I'm not sure. Why don't we do the same thing we just did, but with these two? Excuse me. Swallowed wrong. What would that tell me? X squared, z squared equals x squared, y squared, right? Same idea. Kill off the x's. Z squared equals y squared, which means, oh, let's solve this one for y as well, or no? What do I want to solve for? Let's just solve for y, and then we'll see how this is going to work. Plus or minus z? Okay. Now remember, this equation is y is equal to plus or minus x is the same as saying x is equal to plus or minus y. And this is the same as saying z is equal to plus or minus y. Okay, you all good? What now?
Equation 4.
Equation 4. Equation 4. Let's look at equation 4. Let me erase some of this. I'm still continuing over here. Equation 4. Okay, equation 4, let me write it down first. X squared plus y squared plus z squared equals 1, right? But I can replace, let's replace x with what? Plus or minus y, right? So replace this x with plus or minus y, but then squared, plus, okay, let's just leave y squared as y squared, right? And then plus, what can we replace z with? Plus or minus y? Must equal 1.
For squaring it, do we really need the minus?
We don't need the plus or minus. I'm just pointing out that what I'm doing is I'm taking these two, right, and I'm plugging them in over there. So really, doesn't this turn into y squared plus y squared plus y squared equals 1?
Yeah.
So 3y squared is 1. So y squared equals 1/3, which means y is plus or minus the square root of 1/3. Okay. All right. If we know what y is, do we know what x is? Do we know what z is? Kind of, right? Kind of. So let's see if we can't list out some things now. I'll have an x, a y, a z, and a lambda, which I may not even find, right? X, y, z, lambda. All right, I know what y is, right? Y is, let's start one at a time. What if y is root 1/3? What's x? Plus or minus root 1/3, right? So there's actually two possibilities there. And then z is plus or minus root 1/3. And who cares what lambda is, right? But I know it's there. And then I have to do y is what, negative? And won't I get the same results? Which means I should just do this. Be careful. That doesn't mean there's two scenarios here. How many different scenarios is this? 6, right? All positive, right? All positive, all negative. Or positive, negative, negative. Or positive, negative, positive. Or negative, yeah, there's a lot. You have to look. There might be more than 6 there. But here's the thing. Does it really matter if we take all the positives and negatives here? Not in the grand scheme of things. Because all of these different combinations plugged into this function give you the same result. Do y'all see that? Because they're squared, isn't that just going to be like 1/3 times 1/3 times 1/3? Yeah. So what I can say is that if I evaluated that function, right, at any of these, I just get 1/27, right? Because it'll be, this in here will be 1/3, 1/3, 1/3, 1/3 times 1/3 times 1/3, 1/27. Now, I don't know if that's a max or a min yet, do I? And I've only assumed that all the x, y, and z's were not 0. Now it's time to start looking at if they were. All right. So I'm going to continue now, right? We have a new assumption to make here. When I'm doing my work on a piece of paper, what I like to do when I have an assumption like this is I like to put like a bracket down the side, and then when I'm done, I close the bracket when I'm done with that thought. And then, now I'm going to go to a new suppose, right? So I'm going to start a new bracket, and now's my new assumption here. Why don't we do this? Let's suppose that what? X is not 0, y is not 0, and z is 0, right? Let's assume that. That would be, we're assuming these two are still the same, but that one's no longer not 0. Let's see if we get any problems. Do we?
Equation 3.
Yeah.
Equation 3 is a problem?
No, it's
No, that would be 0 equals 0.
No, that would be okay because 0 is 0.
Oh.
We would do the equation 2. Wait, no, because lambda 1 could be 0.
If z is 0, look at the first equation. What does equation 1 tell us? If z is 0, 0 equals lambda times x, right? And what does equation 2 tell us?